All right, guys, last form that we're going to talk about is graphing in factored form. Now, sometimes factored form is called intercept form, and I think you'll see why. So we're going to do that on page 108 and 109. Oh my gosh, am I off on pages? No, that's right. I don't know why I had a moment where I was like, that doesn't sound right. Alrighty. So like I've been doing in all of them, on 108, we're going to do some extra examples in a separate video. We're going to start on 109 here. So graphing in factored form is kind of tricky. I like it a lot because the equation itself gives me a lot of information, but it doesn't give me that key piece of information again. The key piece is to have that vertex. And again, I don't have it when I'm in factored form. It's such a disappointment. As always, though, we want to identify what form we are in. So I will know that I'm in factored form. We can kind of think of it a couple of ways. If there are two sets of parentheses, boop, boop, I can kind of know. Or if there are two x's, but no x squared. That kind of tells me that I'm in factored form. Because the thing is, standard form has two x's, but one of them is an x squared. If I see two x's, but neither of them are squared, then I kind of know that I'm in factored form. Or sometimes the easier way is just look for those two sets of parentheses. Now, like I was saying, factored form is kind of tricky like standard form is, where I do have to do a little math to get what I really need, which is that vertex. But there are a few obvious things when I'm just looking at the equation. So the first thing, as always, that we can identify by looking at our equation is that a value n and a value is still and always our slope. We can do it once, and we always have to do it as rise over 1. At least one thing stayed consistent. When it comes to these other values, the graph is trying to be helpful. It's trying to give you information. And so when I look inside the parentheses, each of these values here, P and Q, will become opposite. So like if I see x minus 2, it's really going to be positive 2. Or if I see x plus 7, it'll really be negative 7. But furthermore, your P and your Q value are your X intercepts. And so that's kind of why this form is sometimes called intercept form, because that's what it's showing you. It's showing you your X intercepts. And again, we want to be careful because they're going to be opposites, or opposite of what you see. Exclamation. Okay, so as always, we want to talk about our steps for graphing success. Like, what order do I do things in? What sort of math do I have to do? Oh my gosh, and like, this just goes to show, like, I have x-intercepts, which are great, but I do not have the vertex, which is that most important point. So we are going to have to do some math to get it. So we are going to first find and plot those x-intercepts. Those are helpful. Remember, those are our P and Q values, so it'll look like P, 0, and Q, 0, but we want to remember that they are opposites. Okay? Now the thing is, because my graph is symmetrical, when I have those 2 points on my x-axis, they're equally apart from that center line, so I can just sort of do until they meet in the middle. So the second thing that we want to do is count to the middle to get my axis of symmetry. And I do want to write it down like x equals whatever that number is, because when I find that middle, somewhere along that middle line is my vertex. And so I can figure out how high or how low that vertex is by taking my axis of symmetry and plugging it in for x. So plug in the axis of symmetry to get the y value of the vertex. So like my vertex is going to be this axis of symmetry, x value, comma, whatever I got when I plugged it in. So again, it takes some work to get my vertex, but I have to have it. And then lastly, I can kind of get another point, although at this point you already will have 3, so you should be able to see your graph. But if you want to make it look real good, as always, we can use A as our slope one time and rise over 1. So this one is a little bit more complicated, which is why I kind of save it for the end. But I do like it because it gives us the most information. And for me, it really makes sense because we understand that symmetry portion of it. But it can sometimes be hard to forget, like, wait, what am I supposed to do next? So let's try it out. All right, so step 1 here, we want to find and plot our x-intercepts. Those x-intercepts are inside parentheses, and they're separate points. So like before when we were doing vertex, we took these and made them 1 point. These are each individual points. So the first one will be at -1, 0, because always opposite. And then the second one will be at 3, 0. Because of their x-intercepts, they go in the x position, and then y is just always 0. Okay, so if I go to plot those, I'd plot -1, 0 and 3, 0. And here's where I'm talking about step 2. Step 2 kind of happens on the graph. Now there is a low-key formula for it. I guess I'll give it to you. You kind of add up P and Q and take half. But I just like to do it. So I'm just going to do until I get to the middle. Like I'm just counting equally on both sides. Like I'm just walking in until they meet evenly in the middle there. And so because that middle happens at 1, I know that my axis of symmetry is at 1. That also tells me that the vertex x value is 1. But now, like part 2b, I have to plug that number in for x to get the y value. So just like we did for standard form, we have to plug her in to figure out what y is. So we got that -2 out front, and then in place of x, I'll put 1 plus 1, and then 1 minus 3. Now the way that I evaluate this is a little different. I need to do what's in the parentheses first. So 1 plus 1 is 2, and then 1 minus 3 is -2. And all these numbers are just smashed together, so they're all just being multiplied. So like 2 times 2 times 2 is 8. And it is positive because we have 2 negatives, so they cancel each other out. So the y value here is 8. Oh my word, that's not going to fit on this graph very well. So my vertex now I know is at 1, 8, which is just off this graph right here. Now the third thing that I can do is use that slope once, and my slope is always that front number, so -2. And from here we'll go down 1, 2 over 1, and we can flip it over and put it on the other side. Okay, so you know, in terms of the math that you do, I feel like the math that you do is a little bit easier. It's just a little bit weirder because I have to do that counting thing on the graph to figure out where the middle is, which sometimes people forget that they can do that. So let's try a couple more. Okay, so starting with this one here, I can tell that I am in factored form because I have 2 sets of parentheses. I can also tell because I have two x's and neither of them are x squareds. So the first thing that we always look for are our x intercepts. And there are two of them. And they come from the numbers inside parentheses, but opposite. So when I look right here, I'm going to take the 1, 0. And then when I look over here, I'm going to take the 4, 0. Okay, so then I go plot those. We are at 1, 0 and 4, 0. And I like to go plot them right away because then I can just count on my graph to figure out where the middle is, and I think it's going to suck. Because I count in one square, and then like there's not another square for each of them. They kind of have to share that square, which means I'm right in the middle of 2 and 3. Sorry, that's kind of blurry, but that is a 2 and a 3. So the number that's right in the middle of 2 and 3 is 2.5. Now, some of us I know really like a formula. So what I can do here is I can add up those x's and take half, because that's what I'm doing. Like I'm finding the halfway point. And so like 1 plus 4 is 5, and 5 over 2 is half. So if you like a formula better, that's what this was right here. Okay, but I just like to count. And then I put in my line of symmetry. Now, somewhere on this line is my vertex. And so I need to find how high or how low it is by finding the y value of the vertex. And I can find that y value by taking what I got for x and plugging it in. So I'll have 3 times 2.5 minus 1. I'm doing a decimal again. On a graph, it's kind of better. I hate to admit it. And then we'll do 2.5 minus 4. Okay, so we want to do what's inside parentheses first, because if I'm following order of operations, parentheses comes first. Siri, stop listening to me. Goodness me. So 2.5 minus 1 is 1.5. And then 2.5 minus 4 is negative 1.5. Now there's so many fun patterns to notice about how these numbers in the equations relate to the graph, but it's just too much. We'll have to talk about it in Algebra 2. When I multiply all these up, I think I'm going to do it on my calculator because the decimals freak me out. Okay, let's just do it. So we'll do 3 times 1.5 times 1.5. And it is going to be negative because I have one negative, so negative 6.75. Yuck, yuck. Okay, so this tells me that because that middle value, that x value was at 2.5, and then when I plugged that in, I got that the y value was negative 6.75. That is my vertex. So now I can follow along my axis of symmetry down 6 and a little extra, but not quite to 7, because 0.75 is almost there, but not quite. Then I can use my slope, although I can already see like this is a point nut parabola because I have the two x-intercepts I can connect to, but I can use that slope of 3 to get another point. So from here I would go up 1, 2, 3, and over a full 1, which kind of puts me in the middle of a square. Flip it over, put it on the other side, and then we can sketch this little parabola out. What a cutie. Point nut parabola has a minimum. Kind of narrow. You'll love to see it. All right, last one that we'll try in this video here. And this one is a little bit sneaky. Sorry, gotta stay hydrated. This one's sneaky because I told you guys to identify that something is in factored form, we want to look for 2 parentheses. But this is in factored form, and I don't see 2 sets of parentheses. So kind of the other hint is to look for 2 x's, but no x squared. And so this has an x and an x, but neither of them are squared. So this is low key in factored form, and that's why I wanted to do a problem like this, because one of my x-intercepts to me is super obvious. It's 4. The other one, however, is a little less obvious because, like, where did it go? Normally, I'm looking for a number inside parentheses being added or subtracted. And, like, this one doesn't have that, which means it's at 0. Because if it doesn't have a number in there, it's nothing. So 0. Okay, so once I have my x-intercepts, I'm going to go plot them. We got 0, 0, and 4, 0. Second step, I like to find that axis of symmetry, which is going to be right in the middle, at 2. The axis of symmetry is helpful because it is the x value of my vertex, and now I just need to figure out how high or how low that vertex goes. So to figure out how high or how low, I need to know the y value, and I can find the y value by plugging in the 2. So in place of this x here, I put a 2, and in place of that x there, I put a 2. I want to do what's inside parentheses, and 2 minus 4 is negative 2, and then we're just multiplying all these numbers up. So 2 times 2 times 2 is 8, and I do need a negative. Oh my goodness, it's not going to fit again. I'll go plot that point at 2, negative 8, which is just off my graph. And I can already see that this would be a pointing up parabola. But just to kind of help myself graph it a little bit more nicely, I can, and like get a better curve, I can use that slope of 2. So from here I can go up 2 over 1, but I can't do it any more times after that. We can only do it once, and then flip it over, put it on the other side. And then sketch that little cutie out. So we have, again, a pointing up parabola. It is a minimum. It's looking real cute. All right, I'll see you guys on the next one where I'll do a few more examples in factored form.